All right, we're doing the next part of our video. We did break this section up. This is going to be the second part. So we're going to look at numbers 11, 13, and 16. If you notice in the bottom set of directions, it says numbers 11, 13, and 16. There are logarithms on one side and a constant on the other side. And so if you look at those three, you notice it does fit those. And so it starts similar to the other one. It says condense the logarithms into one logarithm. So in number 11, actually in all three of these, there's a minus sign, it's subtraction. So you're going to change it to division. But on the quiz, you might have a plus sign here, which is similar to number 14. A plus changes to multiplication. So just throwing that out there. So number 11, we are going to condense this. So this is going to be log base 3 of 5 over 5x equals 2. And now we don't have a logarithm on both sides, so this is where we do step 2. We change to exponential form. So this is the the base of the logarithm 3 is going to be the base of our exponent. So it's 3 to the second equals 5 over 5x. So this is going to be 9 equals, and in this case, it doesn't always happen, but these both reduce to 1. So we have 9 equals 1 over x. We have a variable in the denominator, so we'll multiply both sides by x. On the right side, it cancels. And so we'll have to come up here. We have 9x equals 1. We divide both sides by 9. And we get 1/9. Which that's a great answer. It says leave answers as a fraction or round to the nearest tenth. 1/9, we can just leave it like that if you wanted to. That is 0.1 continuing, so 0.11. All right, on to number 13. Very similar. So back to step 1 in that bottom set of directions, because it's a logarithms on one side and a constant on the other. So we are going to condense. So this is going to be log base 9 of x over x minus 5 is equal to 2. So we condense the left side. It's equal to a constant on the right side. So now we change to exponential form. So this is 9 to the second equals x over x minus 5. The x's cannot cancel here because there is not an x in this term. You would need an x in every single term. So nothing cancels. And so we multiply both sides by the least common denominator. Well, maybe I wanted to, this is fine. What is 9 squared? Well, 9 squared is 81. So this is, we can rewrite it. So this is going to be x minus 5 times 81 equals x. Now we're going to solve, so we have to distribute that 81. We'll do one more line here. So this is going to be 81x minus 5 times 81. It's going to be 405. We can check it on a calculator. That might be something you do on a calculator. So we've got 81 times 5 is 405 equals x. We're out of room, so I'm actually just going to rewrite that whole thing. So we have 81x minus 405 is equal to x. And I guess the quickest way is just to get all the x's on the right side. So we could subtract 81x from both sides. Don't forget negatives. So this is negative 405 equals negative 80x. And then we can divide both sides by 80, negative 80. I'm sorry, negative 80. That does reduce by 5. So that's like 81 over 14, but we might just be better off dividing. So negative 405 divided by negative 80 gives us 5.0625. The directions say round to the nearest hundredth, so we will do that. So x is approximately equal to 5.06. Can actually zoom in a little bit here instead of writing so small. Number 16, very similar, probably I think a little bit simpler, because when we write this in log form, we've got log base 8 of x minus 1 over 5 equals 1. And then we change to log form, so 8 to the first, which is just 8, equals x minus 1 over 5. And it is a little easier to solve because it's not a variable in the denominator, it's just a 5, so we multiply both sides by 5. 8 times 5 is 40, equals x minus 1. Those canceled, and add 1 to both sides. And we get x equals 41. I should have been mentioning it more often, but make sure you can put 41 back in here. It doesn't, we're not taking the log of a negative, and so that works out. And so that was for 11, 13, and 16.